Partition chromatography is used for the separation of the mixture of amino acid and peptide. The molecule of the mixture will partition between the stationary phase and the mobile phase. It highly depends on the relative affinity of each one of the phases. Partition chromatography can be undertaken in two ways: paper chromatography and thin layer chromatography. For the paper chromatography is used for the separation and identifying mixture, either it can be color or color, and the mixture used are amino acid, sugar derivative, and the peptide. The other name of the paper chromatography is liquid partition chromatography. For the thin layer chromatography, it used for the separate the mixture by using a thin stationary phase supported by the inert backing. The reason why the TLC is widely used in the industry because the simplicity, relative low cost, high sensitivity, and high speed of the separation. There are three types of the paper chromatography. The first one is ascending paper chromatography, descending paper chromatography, and two-dimensional chromatography. All of three consist the two phases, stationary phases and the mobile phases. The differences between the ascending paper chromatography and descending paper chromatography are the location of the solvent is stored and the direction of the solvent is flow. For the ascending paper chromatography, the solvent is stored in the pool at the bottom of the vessel, while the solvent in the descending paper chromatography is stored in the trough at the top. The direction of the solvent flow in the ascending paper chromatography is upward, while the direction of the solvent flow in the descending paper chromatography is downward. The filter paper in the ascending paper chromatography is supported by the clip at the cotton tree. So, the spotting light will rise up by the capillary action against the force of the gravity. For the descending paper chromatography, the fillet paper is supported by the paper support. It will allow the solvent to flow down the paper by the gravitational force. Commonly, we will use ascending paper more, but if it cannot be done, the descending paper chromatography method will be used to replace the ascending paper chromatography. Two-dimensional chromatography is used to separate a complex mixture of the substance by a single run with the one solvent system. In such a case, a second run is carried out by a different solvent system in the direction perpendicular to the first run. The advantage of using two-dimensional chromatography is it enhances the separation of the complex mixture into individual components. The working principle of the two-dimensional chromatography is quite similar to the ascending paper chromatography. The differences is at the B stage. The direction of the solvent flow occurs upward, but it very slow and takes several hours. If there is no Brenner separation, we need to proceed to the C stage. Before that, we need to turn the paper 90 degrees clockwise and use a different solvent. If we get the satisfactory separation, we will stop the separation. If not, we need to repeat again the C stage. Paper chromatography consists of the two phases, stationary phase and mobile phase. Stationary phase is actually the chromatography paper, contain the cellulose fiber material. The example of the material we can use is ion exchange paper, silica or alumina impregnated paper, acetylated paper and carboxylated paper. For the mobile phase, is it the solution of NH3, butanol and water. Firstly, we need to put the chromatography paper in the solution. Then, ink spots are centered and evenly spaced on the starting line. After several minutes, solvent front advance upward and spot run up. When the solvent front reach the finish line, we need to immediately remove the paper from the mobile phase. We need to remember that different compounds have the different rate because of the differences in the solubility in the solvent and differences in their attraction to the fiber in the paper. Chromatogram is the paper chromatography we use in the separation. It consists of the spot pointed represent different type of the compound. It can be recognized by their different color. To know what the color represents that compound, we calculated the RF value. Different compound will show the different RF value. RF value is the ratio of the distance traveled by the sample divided by the distance traveled by the solvent. If the RF value shows 0, that means solute remain in the stationary phase and immobile. If the RF value is 1, it shows that solute has no affinity for the stationary phase and travel with the solvent front. The advantages of the paper chromatography are first, it very easy, simple, rapid and highly efficient method of the separation. The second one is the separation of the wide variety of the materials such as amino acid, sugar, oligosaccharide, oligopeptide and so on. Third, it can be applied even in a microgram quantity of the sample. The fourth, it is not preferable for the separating the protein because protein is not soluble in many types of the solvent system and some of them can denature the protein structure. And the lastly is it more inferior in the revolving the power. The another type of the chromatography can use is thin layer chromatography or TLC. Thin layer chromatography is also used to separate the mixture. It consists of the two phases which is stationary phase and liquid phase. Stationary phase consisting of a thin layer of absorbent material, silica gel, aluminium oxide or cellulose, immobilized onto a flat inert carrier sheet. Liquid phases consisting of the solution to be separated which is dissolved in the appropriate solvent and is drawn out the plate via capillary action separate the solution based on the polarity of each component. The advantages of the using TLC is monitoring organic reaction, determination of the pigment a plant contain, detection of the pesticide or insecticide in the food, and lastly is identifying compound present in the given substance. The working principle of the thin layer chromatography. Firstly, a small spot of the solution contained the sample is applied to a plate. Next, the solvent moves up the plate by the capillary action and mix the sample mixture. Then, the plate is then dipped into a suitable solvent such as hexane or ethyl acetate and placed in a sealed container. And then lastly is the different compound in the sample mixture travel at a different rate due to the differences in their attraction to the stationary phase and because of the differences in the solubility in the solvent. As we see, the working principle is quite similar to the paper chromatography, but why we are suggested to use a TLC more because of the some benefits such as TLC is faster run, better separation and the choice between the different stationary phase. For the paper chromatography, the material for the stationary phase used is the paper. It's more cheaper and sufficient for what you need for. For the TLC, it uses a different material of the stationary phase. Usually, it uses silica or alumina as the stationary phase material. It had better separation, faster to run, require less sample to work effectively, better selectivity, more flexibility in separating different kinds of the chemical, and can withstand stronger solvent and color forming agent.